Good evening. We're happy to have everybody here this evening. Our speaker this evening is Dr. Jim Steichen from the Biological and Agricultural Engineering Department. And Dr. Steichen has done a lot of work related to water. And so the topic this evening deals with water and the sustainability and water in Kansas, which is a very important issue. Thank you very much for being part of our program.
Thank you. How do we do this?
Well, you can put it in your pocket, and
Okay.
then you can put that on your shirt.
Okay.
Okay.
This will work. Okay, so my talk is on the same theme as the previous ones in relation to water supply in the state of Kansas. I'll go back to definitions. Our first speaker back a month ago in late August showed this definition of sustainability related to the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So I'll let you make your own judgment as to how well different kinds of water supply issues are being done in the state. The outline that I'll follow is to begin by talking about the water budget for Kansas. How much water do we get? How do we get it? Where is it stored? And the second piece will deal with water laws and how it's determined who gets to use water under what kinds of circumstances. And so this is more of the legal, social kind of side of the question, and look at some of the tools that are available for handling shortages and challenges. And then finally, how some of these concepts are used in applications to Kansas issues. Okay, the hydrologic budget is essentially something like doing your checking account. For a defined area, we're saying that inflow minus outflow, the flow of water, is equal to the change in storage over some period of time. So the defined area might be a watershed, an area that drains water to a stream, or in this case, we'll just say the boundaries of the state of Kansas. The period of time can be a year, could be a longer period of time, but you do this over some period of time. And like I said, the similarity to a checking account, you'd make deposits, you take withdrawals. You can take more withdrawals in some months, but your storage of cash in your account will go down. Okay, this graphic shows the state of Kansas, and the biggest input is precipitation, so around 27 inches as an average over the state. Now, down in the southeast, it'll be above 40 inches in an average year. Out near the Colorado border, it may be more like 15 or 16 inches. Of this 27, about 23¼ inches is evaporated or transpired through plants. So this is the water that's evaporated from ponds and reservoir surfaces, or the water that goes through growing plants. So far and away, the biggest use of water is just keeping growing things alive. The next piece is about 2½ inches that turns into runoff. So this is the water that, when it rains real hard, the water doesn't soak in, or the soil is already getting wet, and that water runs down the hill and eventually ends up in a ditch and gets to a stream. So a depth of water of a little over 2½ inches over the whole state is the amount of water that eventually gets to a stream or to a reservoir. Then about a little over 1½ inches is the amount of water that is used for beneficial uses by industry, by cities, municipalities, and for irrigation. Of this 1.56 inches, the bigger piece comes from groundwater. Over an inch comes from groundwater. Only 44/100 comes from the streams or reservoirs of surface water. And that's all of those sort of where you take water out of from a reservoir, from a stream, or by a well and be used. And of this surface water, 75% is used by power plants like Jeffrey Energy Center over in Potawatomi County. Of the groundwater, over 92% goes for irrigation. So this is of a bigger number, far and away the biggest use of water that's been diverted, not the water that just falls on a pasture and is evaporated. Irrigation is the biggest. Okay, this is a table that is essentially the same kind of data over the numbers were calculated for a different period of time. So instead of 27 inches, we're showing precip is 28 inches, but still the relative size is what I want you to think of. So an inflow, only about a ½ inch is stream flow coming into the state from the Republican River, the Arkansas River from Colorado. We have some water that drains out of the state down here on the outflow side. But if you add up the inflow and compare it with the outflow, we're deficit spending. We're using more water than we get. So what happens is that our storage is depleted. So how do you suppose we're balancing our checkbook? What would you suppose by observation?
The level of the Ogallala goes down.
Yeah, so anyway, it's coming from groundwater almost entirely. So, okay, this is a graphic from the Kansas Geological Survey, and rather than talking about numbers, I think the size of these circles will be a little easier to grasp. The size of the circle represents the amount of water that's used in a county, and this is the water use that's reported. So this is water that's diverted from a stream or a reservoir or from a pump. And so if we look at Wichita, this size is a number of something like 135,000 acre feet. So it's a pretty good sized number, but this is the biggest city in the state, biggest county in the state. And a little over half of it is red, which represents municipal use. Yellow is industrial, so that's another third. But even in Sedgwick County, about, well, I guess a third of the total amount in Sedgwick County goes to irrigation. Now look at the size of this circle compared with lots of these out here in the far west. A lot of those counties may only have 3,000 or 4,000 people in them even, and they're all nearly solid blue. So that's irrigation. This is from the Ogallala or the High Plains Aquifer. So in terms of quantities of water being used, far and away more is used for irrigation than is used for our big cities like Wichita, Wyandotte County, Johnson County. This circle is the biggest one. It's in Douglas County, Lawrence, and it's a kind of an unusual case. There's what's called the Bowersox Dam that was built across the Kansas River about the 1880s, and that diverts water into generating works. They have wheels. The water flowing over the wheels spins a turbine that generates electricity. So it's generated electricity from hydropower for over 100 years. And so they have the biggest water right in the state, which is way more than even the irrigation from a county. But the water just comes in, spins the wheel, the water goes back in the river again, so it's not really used up. But otherwise, you can see even counties like Shawnee County, Potawatomi County has a lot that's used by industrial. That's probably for Jeffrey Energy Center as a big piece. Okay, so the Kansas water budget is in deficit, and we make up this deficit primarily by drawing extra water from the aquifers, especially the Ogallala. For surface water basins, and this is, last week we had a discussion about the Kansas River system, which covers the northern half of our state. So the headwaters for the Kansas River began out in eastern Colorado. The Republican goes through Nebraska, comes back down the Smoky Hill, and we learned last week also that this is the largest prairie basin for a river in the world. The other half of our state is the Arkansas River. About everybody else calls it the Arkansas River, but such is how it is. But the Arkansas begins out at the Continental Divide in Colorado and drains into Oklahoma. And these other areas are where the tributaries flow either into the Missouri or into the Ark. The other big piece of our water system, as we've alluded to, is the Ogallala. In the textbooks for groundwater hydrology and hydraulics, they refer to this as a high plains aquifer in talking about this entire system, and begins down the southern part of the Texas Panhandle, south of Lubbock, and goes all the way up into the southern part of South Dakota. So there's a huge quantity of water. The development of the High Plains Aquifer began down in Texas. So they were using this shortly after the end of World War II, maybe earlier. They're growing cotton. And so this has been pumped longer and heavier than any other part of the Ogallala. Now, in some ways, you can get the feeling that an aquifer is sort of like a lake. You know, you put a straw in it and you can pull the water out from wherever you come into it. But if you look at these, there's lots of places where it's like here, it ends and there's practically nothing where it's connected. And even here, there's a very small connection. Once again, up in western Kansas, we have another area where there's not a very big connection. So there are places, you know, that are totally missing in terms of having a large aquifer. The rainfall that we have in the state, in the southeast, the wettest area, 40 to 45 inches in an average year. And each county, as you go further west, you lose 2.5 inches, maybe 2 inches of average rainfall a year. For Manhattan, we're around 34, 35 inches. By the time you get to Salina, it's maybe 29 or 30. Hayes, maybe 24. You get out to Goodland, maybe 16. So you go from, you know, rather wet to semi-arid, at least semi-arid. On the other hand, when it comes to runoff, this is the water that runs off the surface and gets into a stream. We have an even sharper contrast from one corner of the state to the other. In the southeast corner of that 40 or so inches of rainfall, as much as 10 inches in an average year turns into runoff in the streams. But out around, say, Garden City and west, only 1/10 of an inch, just a little bit, ever actually gets into a stream channel. So most all of it turns into evaporation. Manhattan, we're around where we get about 6 inches of runoff a year. By the time you get to Salina, it's only 2. Hayes, 1 inch of runoff. So, you know, the difference between, say, 10 and 8 inches isn't much of a big deal. But the difference between, say, 1.5 inches and a 1/2 inch is pretty significant. You just don't fill up a farm pond very fast that way. The next part of my talk is to discuss water law and the rules that states use to figure out who can use water, under what kinds of circumstances, how disputes, conflicts, when shortages happen, how are those things dealt with. So these are, you know, sort of social type problems. We've been looking more at, say, the technical science side of what we can measure in the first part. So with water rights, it turns out these are primarily a function of the individual states. And really this goes back to our Constitution. One of the amendments, I think it was the 10th Amendment, says that those things that aren't kept as being the responsibility of the federal government belong to the states. So the idea of states' rights, if it's not stated in the Constitution how water rights are to be done, then the states get to decide, and that's how this generally is done. So laws can differ very greatly between states. And Missouri on our east has a very different set of rules than what Colorado uses. So, you know, if you kind of knew how things worked in Missouri and you went out to, say, Boulder, you know, got some land out on the foothills of the Rockies, the rules would be drastically different with what you'd have to do. And the federal government only becomes involved with these kinds of things, you know, when you have treaties, which can include Indian treaties, but federal lands can come into play. But usually this is where states deal with the questions. Okay, for Kansas, what we've done, at statehood, we started using what's called riparian rights. And riparian is a word that was discussed some last week, the term of riparian vegetation. Do you recall what that was connected with? It's the vegetation along the stream. So here we're talking about rights that are connected to owning land next to a river or a lake. However, in 1945, Kansas decided to change their rules and decided to use what's called prior appropriation. So prior appropriation is the kind of rules that Colorado and drier states to the west use, and the riparian rights are what Missouri still does use. Some of the other differences is that Missouri has no statutes in their law books about how water rights are done. All it is they look at how courts have ruled over the last 150 years, and that's how you figure out what you can do. Whereas under prior appropriation, there's a statute that's in the law books, there's rules, regulations, procedures, and a whole slew of things like that.
Is the prior appropriation, does that come from the riparian rights?
No, it's altogether different. Actually, the prior appropriation has some similarities to things like getting a mining claim, you know, when they found gold out in the Sierra Nevadas. Well, the first person who identified, hey, this is it, you know, they go into to the county seat or whatever and makes a claim for searching for minerals on this particular piece of land. And so the first one there got the claim. And so they were probably doing that before they started dividing up water in places like California and Colorado. Okay, now it may seem as something of a technicality, but the third bullet about in Kansas, the water right is not a right to legally own the water. The law actually says that the water belongs to the people of the state of Kansas. However, if you get the right, then you get the right to use the people's water for your own personal benefit, for some kind of a beneficial use. And in Kansas, they made it very clear that we would use the same rules for groundwater as we do for surface water. In many places, different rules apply for groundwater. Okay, so we'll discuss a little bit of what riparian rights is, even though Kansas doesn't use it now. Missouri does, and it can be sort of a contrast, and you can see why we may have followed that initially and it made sense, and then why we changed. But riparian rights are based on English common law, and that means that these were understandings that came about over common practice over a period of time, and courts would tend to rule the way a previous court had ruled under a similar situation. And so going back into, say, the 1600s and 1700s, when people in England had mills for grinding grain and such, they'd have a wheel in the stream, and the flowing water would turn the wheel, which would grind the grain or run the weaving machinery. So this was the power for industry in those days. Okay, so the right to use water is based on just owning land that is riparian or next to streams or lakes. You don't have to apply to the state for anything. Just owning the land gives you the right to use the water. Now, the third bullet, there's some contradictions in this statement, but at any rate, all the same, this is how it would be described in the law book. All riparian owners have an equal right to use water, and then they say undiminished in quantity or quality, which means that you can't grossly pollute it and harm your neighbor downstream, but also you can't take so much water that you deprive the person downstream to use water in a similar way that you are. So the kind of place where this would make sense is where it's pretty wet. There's lots of water. The streams are carrying water almost all the time. And so that, if people were relatively reasonable, you could take some water and there was still enough for people downstream to water their livestock and that sort of thing. And so, it kind of made sense. If you don't have a problem, why create, an office and a lot of legal mumbo jumbo if you don't really need it? So Missouri and most of the states in the eastern part of the U.S. Follow riparian rights. Okay, now we're going to go for a little side point about groundwater. And in this case, we're talking about common law for groundwater. And this is not what Kansas uses. States like Texas, Missouri, and so on have principles somewhat like this. So here the landowner has complete ownership of whatever is under his land, including the groundwater, oil, minerals, all that kind of stuff. So typically this means that you have the absolute ownership of what you can bring to the surface, with some subtle differences from one state to another that we'll talk about a little later. Okay, you can use all of the water wanted without concern for the effects on neighboring owners. And it's used in some states but not in Kansas. So, this allowed you, the water's there, you can take it. Okay, now with prior appropriation, which are the rules that Kansas uses, it's almost a cliche in the water world, but the statement of first in time is first in right is kind of the basis of it. You do have to apply for a permit, and that priority that you get is based upon the date that you first file. And in cases of shortage, if there's not enough water to go around, the person who has the oldest right gets priority over the other people. So in the second bullet, it doesn't guarantee that there's a water source, but it does establish a priority. Now, the kind of situation where this system works well would be like a mountain stream. So just think of a mountain stream out in the Rockies, and you've got snow melt, so the snow is melting, water's coming down the stream. But the amount of snow up there could differ from one year to the next. So they developed a system that would, tend to make it so that the water pretty much gets used, within the state of Colorado. But it gives those who have this right some kind of a sense of their, at least, likelihood of being able to get water. So, the people who have the early rights could take all of what their quantity of water would be, and if there's still water left over, then people further downstream can take from it as well. Okay, it is a real property right that can be attached to the land or even severed from the land. So it's kind of like a deed. And in fact, when you've gone through all the process to get the right, you actually file a document at the county courthouse that's very similar to a deed for land. And that water right can be bought or sold. In fact, it's like for the proposed coal plants in western Kansas, they need water in order to operate that plant. So they have purchased, or at least entered into contracts to buy water rights from those who have irrigation water rights. Now what they have to do is go through a process and determine really how much water the person who's been using it for irrigation actually has, but then they can transfer that water right to the utility and they will cease pumping from that well, and that amount of water can be used for another purpose. Okay, senior rights have priority over junior rights, and even if it means that if there's not enough water to go around, some people may not get any water at all in a dry year. And it's used primarily in the drier western states, and it is the principle that Kansas uses today. Okay, first of all, prior appropriation works best for stream flow based on snowpack, the example of the mountain stream in Colorado. So that a person, typically today there are predictions made on how much snowpack is in the mountains, not only for the ski resorts, but for people who irrigate. And so if they know that the snowpack is only half of what it is normally, a person could kind of figure their odds of being able to get a full amount of water. If you have an early right, then you don't worry about it. But if you have a junior right, there may be some years where you have to make plans where you may not be able to irrigate as much as you'd like. So in times of shortage, the junior rights have to give up. If a person decides to stop using the water for no particular reason, not that, say it was a really wet year, that's not considered abandoning a right. But if you stop using it, then that right ends up going back to the state after a certain number of years, and someone else can get it. The last question, the last statement, is that priority is harder to apply with groundwater because it's a whole lot different than water that's flowing by in a stream. So it's like Colorado, they really would like to manage their water so that no water makes it to Kansas. And in fact, they kind of did that to an extreme maybe a generation or so ago, and we ended up going to court over the issue. But from groundwater, it's hard to say that, it's in the ground underneath you. How is, someone who started pumping 5 years later affecting your water when that person may be 5 miles away? So the principles are a little harder to apply. Okay, next question. Okay, who owns the groundwater? And I'd kind of said that this differs by state. Kansas, Colorado, Nebraska essentially say it's public property. It belongs to the people of the state. In Oklahoma, it's owned by the person who owns the land, sort of like oil. Hey, I've got this quarter section. There's a slice of earth that goes down to the center of the earth. If I can get at it, it's mine. But curiously, in Texas, they have a pretty unusual principle. And they say it doesn't belong to anybody until it's been pumped to the surface, and then it's yours. And this has some peculiar consequences. They have what's called a rule of capture. And apparently this goes back maybe to Texas statehood. I'm not, but it was certainly in place in the early 1900s before large irrigation was going on. And what it does is to prohibit a person from suing your neighbor for pumping water from beneath your own land. So, say if you have a shallow well, your neighbor puts in a big well and lowers the water, you can't complain. And so that's why it's called the law of the biggest pump. And one of the books that I read in preparing for this gave an example of a case that occurred in the suburbs of Dallas. And in fact, it's a place that, anyway, one of the places where they bottle Ozarka bottled water. And you've seen that in the stores. So they just have a big well, and in pumping, they dried up several smaller wells in the neighborhood. And so those people were upset, felt like they should be compensated in some way, went to court, and the court said, essentially, that's tough. He was able to get it out of the ground, it's his.
How do they decide who gets to pump it if nobody owns it?
Well, it's your land, you can put a well down, is how Texas looked at it. And so, if you just have, say, homeowners and you're just putting, say it's in a suburban area and you've got 5 acres, let's say, and you've got a well for your house and the garden and so on, and everybody's about the same, it's no big deal. But somebody comes in with a great big well, they can lower the water table, and that gets to be a lousy deal. Yeah?
How do they deal with contamination if they have that?
With contamination, I think that's an altogether different thing, but I don't know quite how that would work. I think you would have something of a case if you could show that you were harmed by the irresponsible disposal of something from somebody else. But instead, in Texas, instead of changing the state law, what they did, and this was all the way back in 1949, they decided to establish what's called a groundwater management district. So that's the next to the last bullet. So they created this institution, a piece of local government, kind of like a school district that has boundaries, had the right to tax, and people who own land within the boundaries of that district were able to vote for things like members of the board of directors and such. They were able to write rules to control well depletion and various procedures that would be required for people who are using water from groundwater. And so shortly after that time, groundwater management districts began to be established in Texas, and I think they've got maybe 50 or 60 of them. So a big part of the state, especially where groundwater is important, gets around this law of capture thing, and essentially that district establishes the rules, which gives a lot more fairness, to the situation. Okay, so now we'll talk about, the situation for Kansas and, where we are, how we got to where we are today. Irrigation actually began in the 19th century. They were attempting irrigation from the Arkansas River in western Kansas in the 1880s or so. And they were diverting water from the river, putting it into canals, and doing surface irrigation. It was pretty difficult. The government was not involved in any kinds of development like that. So private individuals had less financing, and then when a flood comes along, they kind of get wiped out, and it's kind of a tough deal. So the 30s, of course, was famous for being the Dust Bowl, and it was a great drought. But still, there really wasn't the ability to, pump water from the Ogallala. Actually, I've read that the first well, the significant well into the Ogallala, was drilled in the early 1900s down in the Texas Panhandle. So even though they knew the water was there, it wasn't used until substantially later. And from a practical standpoint, after World War II is when development really began to happen. First of all, large capacity turbine pumps were invented, and these are able to lift water from significant depths at high capacity. And the next invention is the center pivot irrigation machine, and this made a huge difference to the high plains. It was invented in Nebraska. I've forgotten the man's name, but he invented it in the early 50s. He was pretty much kind of a shop mechanic that had lots of invention ideas, and he had patents before he patented this. But he just got to thinking about irrigation. The previous people either put irrigation water in ditches and it on pretty much flat ground and it flowed by gravity, or there were sprinkler pipes, so you had the sprinkler nozzles, but you would have to have a lot of labor to go out and move these pipes around to irrigate different parts of the field. So he had the idea of having a pivot, and typically, so the pivot is down here and it just goes around in a circle. The typical center pivot irrigates a quarter section. So it's the circle inside 160 acres. So that's around 129 acres or so. And this really made irrigation take off throughout the high plains. To give a measure of the economic impact and importance of irrigation, whoops, did that happen? Okay, this is 2002 data for western Kansas, so it'd probably be the 3 or 4 counties north and south all the way to Colorado, representing over 5 million acres of land. And of all of that land out there, about 37% is irrigated, but in terms of the economic value, the irrigated land produces 70% of the income. So being able to irrigate has a very substantial impact on the economy out there. And it's things like fertilizer and pump companies and irrigation companies, more grain, and you've got the cattle feeding business. So by being able to irrigate, there's a huge rollover effect of the amount of economic activity that happens. So this is very important to that part of our state. Okay, so now we get to go back and talk a little bit about geology and aquifers and such. So over on the right, we have the situation where, before irrigation development. So if we went back to, say, 1900, this would be kind of the situation that we have. Okay, first of all, the term aquifer refers to a geologic formation that both contains water and can allow water to be conducted or move fast enough so that it can produce significant amounts of water. So an aquifer, for a rural residence might only need to supply 3 or 4 gallons a minute, whereas an aquifer for a center pivot irrigation machine would need to deliver, say, 600 gallons a minute. But so an aquifer contains water but also can transmit the water. For the Ogallala, it's a formation that's gravel and no clays, gravel and sand, and it was laid down by erosion over a geologic period of apparently about 15 million years. And at one time it was connected to the Rocky Mountains, but the aquifer is filled with water over a long period of time. And so before development you have, this would be the formation. The water table is the point at which, if you dig a hole down at the water table, you would find water standing in the hole. So it's like a dug well. Greensburg, for instance, has a famous huge dug well. If you go down that far, water will be standing in the hole at that point. And even though this water is moving only maybe a foot a day, or probably just a few inches a day, gradually it moves down slope and would cause, the bottom of streams would intersect with the water table typically, and this is how you have a continuous flow of water during dry periods. So perennial streams get their water by discharging water that's in the aquifer. So this is how a stream can carry water during dry periods. Also, you'd have springs. Okay, so this would be the natural condition, and the idea is that you have recharge equal to discharge. So the recharge areas where you have precip, you have natural vegetation, it's using some water, but some still penetrates through the root zone and gets down to the water table. Okay, so now we've got the situation after we've had pumping, a lot of groundwater development for many years. And so we have crops, you still have the precipitation and recharge, but over time, by pumping greater quantities of water, the water table is continuing to drop. Now, if you keep recharge equal to the amount that's coming out of the pump, it will stay steady. But if this has gone on long enough, the water table is dropped below the bottom of the stream channels. And in a case like that, if any water gets into the stream, it goes ahead and recharges the aquifer pretty quickly. But the stream will not be a perennial stream if this is the usual situation. So even though they use the term safe yield, that doesn't necessarily mean that the system is in good shape. It's just that if indeed you keep it at this level, the water table won't drop anymore, but you still won't get water in your natural hydrologic system. So here's the evidence of the impact of irrigation in western Kansas. The blue areas represent perennial streams. And in 1961, this is a map of the areas where streams ran with water flowing in them even during long dry periods. A little over 30 years later, 94, once you get west of about Great Bend or so, there are very few streams that still flow water. And the reason for that is that this water table has just been dropped over that period of time so much that these streams are dry. Perhaps most famous is the Arkansas River, and so 61 it was still flowing as a perennial stream from Colorado, but today it trickles into Garden City maybe, and that's just because we've gotten, I'm not going to get into this in tonight's talk, but we did go to court with Colorado. We have an agreement between states. It's called a compact, and Colorado was supposed to release a certain amount of waters that could reach the Kansas border, and that water wasn't getting to us. So finally, the only thing that we could do would be to sue Colorado in the Supreme Court, and that case went on for 10 years, and finally Kansas did prevail, and Colorado is now releasing more water, so at least the water gets about this far, but then it's dry to about Great Bend. Some other data to show how significant this is. We won't worry about what these numbers are, but it represents the annual flow of water at different stations. So Garden City, Dodge City, Kinsley, Great Bend. In 1950 to about 1970, 75. So you can see there was, at least in wet years, some pretty significant flow. But after about 75, you know, there are just a couple little bumps, and otherwise it's just dry. So even for the Ark, its flow pattern has changed substantially. Now we've tended to use the term Ogallala to represent all of the western aquifers, and perhaps more properly we should separate out two others. One called the Great Bend Prairie, which Great Bend, let me see, Stockton, gotten the name. Anyhow, this area from, say, Dodge City to Great Bend, nearly to Hutchinson or so, is connected to the Ogallala Aquifer, but it's actually a little bit different geologically. The time that it was actually created was in a different geologic period. And then even east of there, an area called the Equus Beds, and it's particularly important. The city of Wichita gets a large amount of their water supply from the Equus Beds. They also have Cheney Reservoir that's over here, some surface water. So these are the major aquifer areas of the state. The black dots represent wells that the state has granted a water right to. So you can see where the mass of water rights exist, and you can match that with, you know, where those aquifers are. This would be the Equus Beds, Great Bend Prairie, and then the three sort of dense sections of groundwater development in the Ogallala. But then there are other areas as well. One would be the Kansas River Valley, and a lot of irrigation occurs along it, you know, from here all the way to a little past Lawrence, by the time, you know, practically into Johnson County. And significant irrigation along the Republican, and we've had a dispute with Nebraska over how much water they're letting us get for surface water from there too, but we're prevailing on that one. So what happened is that after about 20 years of irrigating, and so irrigation rapidly developed in the late 50s through the 60s, and by the early 70s there were, you know, shocking headlines in the Wichita paper about crisis with wells in western Kansas drying up, and that was just the first of many decades worth of similar kinds of stories. So what had happened is that more water rights had been given out than they probably should have, but, you know, it had already happened. But at least Kansas had kind of looked to the south to see, well, you know, what had other places done, and they followed pretty much the model that Texas had, that if they had a situation where they really couldn't manage it with, say, the state system, they could create a groundwater district and develop their own rules and regulations and develop a system that was politically acceptable within their area. So that's what began in the early 70s. So to authorize local landowners to establish these districts, and the purpose was to direct the development and use of groundwater, gosh, I lost, within their district. I don't know what happened to those last words. So they have really clever names for these districts, 1, 2, 3, 4, and 5. But number 1 would be the area that organized first. So this was the place where they had the biggest problems first. And it's an area around Scott City, relatively small, but it's somewhat separated from the Garden City area. So they began, and shortly after that, the Equus beds, just north of Wichita. So really in the center part of the state, but it was being used so heavily, and Wichita was using lots of water, but then there were lots of irrigators as well. So they saw a need to establish some rules that fit their area. And then in a short amount of time, the other 3 were established. And those boundaries pretty much fit, the heavy areas of irrigation development. Okay, so now we'll talk a little bit about the strategies that they followed. We've talked a little bit about safe yield, or at least mentioned the term safe yield earlier. It was the idea of requiring a long-term balance between groundwater pumped and the annual recharge. However, it ignores the discharge into the stream system. So under this strategy, the streams will eventually dry up, which is largely what's happened. So a different approach would be one that has at least sustained kind of in it, that magic word that we have this class about. And it enhances the previous one by using what's called conjunctive management, which means that you'll include the natural groundwater discharge to streams. So you would control at least new wells from being pumped, so that you would consider water flowing into the streams as natural flow as being a beneficial use. And so that approach was used by the 2 districts that are more on the eastern side. So the area around Great Bend and around Wichita are following that strategy, but the people out further west are not. And we can kind of look at, sort of the money date of where we are now. Okay, this heading is the estimated usable lifetime of the High Plains Aquifer in Kansas, and it's based upon being able to get 400 gallons a minute from a well for a quarter section. And that's considered sort of the low end of being enough to have some feasible irrigation. You drop below that, it's not practical to do a whole circle. So the red area, well, let's start with the brown. These are areas that are already below that minimum level. So brown areas, it's not really economically feasible. So this area around Scott City, it looks like, what, maybe 80% of the area has already been dewatered. So their irrigation has already dropped back quite a bit. Up in the northwest area, considerable areas have a similar situation, probably where the water was thinner anyway. In the southwest, there are certainly some, but they're kind of, this is where we have the greatest amount of water still present. But you can see the red would be under 25 years of current usage being left. And Garden City to southeast of Garden City, some pretty big areas that are red. The yellow areas are those that they could continue pumping like they are and have another 100 to 250 years. So areas down close to the Oklahoma Panhandle, Hugoton and such, have much thicker aquifers. So, It's not all treated the same. Now the areas that are in blue, those are ones that have actually raised their water table. So in the last 10 years or so, they've actually recharged some. And the folks here in the eastern area, you've got more rain, they get more recharge. They're managing in such a way that they've actually recharged parts of their aquifer to a significant amount. There's a few little patches of blue out here, but they're certainly a lot smaller. Okay, so this one has a kind of a harsh message. It's the percent reduction in reported groundwater use needed to meet a sustainable yield. I take that as part of meaning that safe yield where it would balance the recharge with what you'd be pumping. And the red areas, you'd have to cut back 75% in order to meet that kind of sustainable yield. And boy, that's a huge part of the southwest core irrigation area and most of the other parts that are irrigated very heavily. And if they cut back from, let's say, 800 gallons a minute to 200, that's not practical to irrigate with. So that's not a very happy situation at all. The folks further east have a better situation in regards to that. The amount of recharge, just natural recharge from rainfall, the yellow and the pale yellow are less than an inch. So, out around Garden City, all of this further west gets less than an inch of recharge. But in the eastern areas, 2 to 4 inches of recharge a year. So that's a more significant amount. The depth to water. Okay, this is how far you have to lift the water. And this has a lot to do with what your pumping costs are, because it takes more energy to lift water 250 feet than to lift it 30 feet. And so the dark brown colors, the darkest one is over 250 feet. So big areas down here where even though they've got a very thick aquifer, they also have to lift it a lot further. So the cost of energy, and today that's natural gas, diesel, electricity if they can get it. And today actually they would prefer to use electricity if they could get it. But if they're having to use diesel, that's a pretty expensive deal at $4.5 a gallon. So that is also a factor in how irrigation will continue in our state. Average saturated thickness. So the dark blues, 200 over 300 feet thick of saturated aquifer still remaining in the southwest. Many other areas, this kind of turquoise is less than 100, and this is less than 50. So you can see why this district just doesn't have as much. This is just an indication of how closely spaced wells are. It's a density distribution within a 5-mile radius. So the darker the color, the more intensely those areas are being irrigated or pumped. And I think this is about the last one. The change in the water table over the last 10 years, so that blue areas have had a rise in the water table. And once again, these areas in the Great Bend and the Equus beds, but further west, not so much. These orange and kind of reddish oranges, 25 to 35 feet or more of lowering of water table in the 10 years. So in the core pumping areas, the water table is being lowered fairly quickly. And realistically, what's happening in many of these kind of fringe areas is that those wells are getting down to where it's 400, 450 gallons a minute, and it becomes less likely that they can irrigate feasibly. And once again, we go back to the groundwater management districts. You have 2 that are in the wetter area, 3 that are in the drier area, and this is the strategy that they're following. The Western groundwater management districts use what's called a planned depletion policy. And so what that means is that they will allow 40% of the aquifer to be depleted over the next 20 to 25 years. That is their management strategy. And the reason for that is that, if they cut back, irrigation would just about come to a halt for all but a handful of people. So it's the idea we're going to get a benefit for the next 25 years in some of these areas. Already, wells in marginal regions are losing capacity and they become uneconomic to use. Now, the two central management districts, and also the state does this to some extent along the river valleys, they're going with this conjunctive management approach, which includes natural base flow of streams. So they're working to keep some flow in the natural streams, and we have a very clear understanding that water in the stream is similar to the water that's in the aquifer. For instance, the city of Manhattan we get our water from wells, but they're next to the Big Blue River, and that is water that flows out of Tuttle Creek Reservoir. So really, what was in Tuttle Creek Reservoir maybe a couple years ago may be kind of infiltrating into our well system. It takes a while for it to get from the river, but as long as there's water in the Big Blue and flowing through the dam, we'll have water in our water well system. And I want to recognize the couple of sources of information. Mario Sophocleous is a researcher at the Kansas Geological Survey. He's written extensively on sustainability issues with water in the state, and a book that was just published in 2006 called Ogallala Blue would be an interesting popular book to read about the impact of the water and the people of the High Plains.
Thank you very much. Any questions or comments?
Yes, Chris. Well, I think that's why the districts have followed the decision that they have, but they had chosen that before the time we had high corn prices. But they're already in real deep as it is, so I think they're just seeing it as, well, this is a temporary resource. However, in the central part of the state and the eastern part of the state, we have aquifer systems connected to rivers that can and should be managed in a long-term kind of system, so that we'd use them in such a way that we still keep the flow in the river system and can use that resource for the longer time period. But I think they're kind of stuck out in the far west.
Other questions? Well, thank you very much. Next week we have David Canada, who is coming to us to discuss leads a group of people that are working in sustainable buildings, and I think you'll find next week's talk very interesting.